Hi everyone, Namaskara. Welcome to Karnataka KCET and Boards. I'm Diksha Kaushal, your chemistry master teacher. Everybody, let me know in the comment section if I'm clearly visible to you and audible to you so that we can start with organic chemistry revision marathon where we are going to do full organic chemistry revision, right, with the help of flowcharts, tables, so that you're able to understand the reactions, right, and also recall the reactions when they are needed in the exam time, right? Okay, so everything that I'm doing today is very important for your organic chemistry to get full marks in organic chemistry, right? Okay, clear. Okay, now let us start this without wasting even a single minute. But before that, I want all the students, all the 94 students present here to like the video, right? All the students here, I want to see how many likes I'm getting over here, right? Because it is very unfair that you're watching the video, right, but you are not liking it, right? So I want all of you to like it right now. It's just 1/3 of the likes, right? That's not fair. Okay, very good morning, very good afternoon, students. Yes. Okay, now let us start it. Let me see how many likes. Very good. Still just 41, huh? Just 41. Even now, it's not even half, right? Less than half. Ma'am, duration is going to be maybe 1 hour or 1 hour, 20 minutes, 30 minutes, something like that. Not more than that, right? So we'll do everything, but in very less time, but in detail, right? Okay. Yes. Now, let us start this. Let us start with the first chapter of organic chemistry, that is haloalkanes, halorines, right? So, talking about the important reactions here, preparation and properties are few things that you need to understand for organic chemistry. So, first is the preparation of alkyl halide. What is alkyl halide? Alkyl is basically an open chain. Aryl is a cyclic chain, like benzene is aryl halide, right? But if you have simple R, right, that is open, that is alkyl halide. Halide means which you have X. X means halogen. So we are talking about alkyl halide. That means we are talking about Rx over here. First thing is the preparation of alkyl halide. Now, for the preparation of alkyl halide, that is from alcohols, right? How to prepare alkyl halides from alcohol? First is with use of PCl5, or you can just simply say PX3 or PX5, right? With the help of these two things, how you're going to get the alkyl halide, right? So if you use PCl5, right, whenever you are using PX5, right, the byproduct is going to be POCl3. Very important. But when you are using PX3, like PBr3, PI3, then you are going to get H3PO3 as the byproduct, right? Okay, because byproduct can also be asked to you. Rest is you will get alkyl halide, that is this OH will be replaced by the phosphorus compound, whether trichloride or pentachloride, whatever you have used here. Here you have used PCl, then that is replaced by Cl. Here you have used Br, so it is replaced by Br. Here you have used I, so it is replaced by iodine. Here you have used very important reaction, that is SOCl2. Right. So SOCl2 is basically thionyl chloride. What is the name? Name is thionyl chloride. Right. SOCl2 is thionyl chloride. Now, when you use why out of these method SOCl2 is preferred, this question is also asked, that why SOCl2 is preferred over all the other methods. The reason is because the byproducts are SO2 and HCl, which easily vaporizes. That is why we will get pure alkyl halide in that case. That is why SOCl2 is preferred here, right, because of the gaseous byproducts. Next is, if you use, let's say, Lucas reagent, that is HCl anhydrous ZnCl2. With that, what you will get with Lucas reagent, HCl ZnCl2, OH will be replaced by Cl over here, right? Okay. Now, next is very important, that in Lucas reagent, we will also do that for the test of 1 degree, 2 degree, 3 degree alcohol, that is Lucas reagent. So basically what will happen, that in Lucas reagent, turbidity, that is cloudiness, is formed, and they will ask you how you differentiate 1 degree, 2 degree and 3 degree alcohols, right? So now here what you need to understand that with why turbidity appears immediately with 3 degree alcohols. 3 degree alcohols are the fastest. So there is a race between 1 degree, 2 degree and 3 degree, right? So which is the fastest among them? Which is the fastest? 3 degree tertiary alcohol are the fastest, turbidity appears immediately. 2 degree alcohol are very slow, right? Okay, after 5 minutes turbidity will appear. 1 degree alcohol are the slowest, right? That means the turbidity will appear after prolonged heating, right? Okay, so that's why that is a differentiation, right? That part is also done. Now, these reactions are mentioned in your NCERT, right? So I'll just show you that. First is when you have HBr in NaBr H2SO4, then you can replace this OH with Br, right? If you have HI in presence of Ki and H3PO3, you can replace this OH with iodine. These are the other methods of preparing bromide alkyl bromide or alkyl iodide, right? This is when you use thionyl chloride in the presence of pyridine. It's a very, very important thing, right? Okay. You don't need to get into detail of that. Just remember, when you use SOCl2 simply, then it is a SN1 reaction. When you use SOCl2 with pyridine, it is SN2 reaction. That's it. The products are same, right? Okay. Now, next is preparation of alkyl halide from alkenes. From alkenes, how it is prepared, let us talk about that, right? Okay. Here, basically, the question that is asked is based on Markovnikov and anti-Markovnikov rule, right? Okay, let me see how many of you know that what is Markovnikov rule and what is anti-Markovnikov rule. Let us see that in the comment section. Yes, guys, let us see that over here. Very good. Now, if you talk about alkene, right, we will add HBr, HCl. Let us say, simply we are saying HX we are adding, right? So whenever simply you are adding HX, it follows a Markovnikov rule. Just how to remember Markovnikov? Rich and poor. It's a bond between rich and poor, right? That means the one that is rich, okay? Out of this we know that which has more electron density, that is which is more electronegative, that is Br. So this is rich. Rich will go to the poor person. Poor person means which has less number of hydrogens. We know that out of this is having 1 hydrogen, this is having 2 hydrogen. So Br will be attached to which thing? To the less number of hydrogens when you are not using any peroxide, right? So if you simply add HBr over here, let's say you are adding HBr in the presence of CCl4, or simply it is written HBr, so it will follow Markovnikov addition, that is rich to poor, rich to poor. But when we talk about when you're adding peroxide, then anti-Markovnikov addition it is going to follow. So anybody, anti-Markovnikov addition? Very good, very good, very good. Very good, Abhilash. So, anti-Markovnikov addition is when poor is below, rich is going to rich only, right? So, here, rich person, that is Br, that is more electronegative, it is going to attack on that carbon which has more number of hydrogen. That means this particular carbon, so it is will be CH2Br. That is done, right? Okay. Now, anti-Markovnikov rule is applied when you have peroxide, but anti-Markovnikov rule is not applied if you have HCl, HI, that will not be applied. Let's say if you have HCl in one reaction, in one you have HCl peroxide, let's say H2O2 I am writing here, peroxide. Same product will be there. That is Markovnikov addition only. It will follow only in case of HBr. In the presence of peroxide, anti-Markovnikov rule is followed. This is a very, very important statement, right? Okay. Next is HCl. Whether you have peroxide or not, it will give you Markovnikov addition only, right? HI also, whether you have peroxide or not, it will give you Markovnikov addition only, right? Next, very, very important, that is if you have Br2 CCl4, right? Br2 you are adding and CCl4. So whenever you have Br2 in the presence of CCl4 and other is Br2 in the presence of very high temperature, or they can also write H mu over here. So how you answer these two things, it's very, very important that when you have Br2 in the presence of, let's say they have written sunlight or they have written very high temperature, these are the exact questions from your NCERT exercise, right? So here what you will do, allylic position, that means this is the double bond, right? Next to the double bond, you will have one carbon. Br will be replaced on that carbon, right? Even if you have NBS and CCl4, NBS is N-bromosuccinimide, right? They will not ask you the full name here. They will just write NBS, that is the reagent, right? Here also you will get the same product. But if you have Br2 in presence of CCl4, then what will happen? This double bond will break and you will have attached Br on both the sides. That is dibromo, right? That will be formed. Understood, right? These are some very, very important reactions that will be directly asked to you, right? Next is preparation of alkyl halide from some other reactants, right? So first is Finkelstein, then Hunsdiecker and Schwartz. These three very, very important naming reactions that you have. If you talk about Finkelstein and Schwartz, these are halogen exchange reactions. You will already have a alkyl halide. You will add some fixed reagents on it and you will get the desired product. For example, let's talk about Finkelstein. In Finkelstein, you have RCl, right? You have alkyl chloride. Then you add NaI, that is sodium iodide. In presence of acetone, you will get alkyl iodide, because iodide and fluoride are very difficult to prepare. That is why we use halogen exchange reactions. In Schwartz reaction, what you have to do, you have alkyl chloride, you add AgF, right? That means you use any inorganic fluoride and you will replace this Cl with the fluorine over here, right? Next is Hunsdiecker reaction. So what is Hunsdiecker reaction? So basically there is a story that I will tell you. So basically what happened, there is a girl named Roxa, RX, right? There is a girl named Roxa. Roxa, Finn is a friend of Roxa, right? Now, when Finn asked Roxa to do some fashion means fluorine, to do some fashion, Roxa said, no, right? I will not do that. And what is acetone? Acetone is there in the nail paints, right? So, Roxa said, no, I will not do that. So, that is how you can remember Finkelstein, RX and NaI, right? Now, Swati is her best friend. We all know that girls always follow their best friend, right? Not their boyfriends, right? So, here there is Swati, right? So, Swati said, Roxa, do some fashion. Then Roxa was like, okay, I'll do that, right? So, Ag is what? Silver fluoride, right? She wore some silver chain or silver ring, right? And after that, she had this fashion replaced by this Cl, right? Okay. So, basically, fluorine will be there. So, it's just a random story to remember things. Now, Hunsdiecker reaction. Hunsdiecker reaction is when you have COOOAg. That is, this is the salt of silver that you will have. Now, how you can remember this? You can remember this with the help of, for example, let's say you have Cl2. When you add Cl2, what will happen here? This Ag will be eliminated. This CO2 will be eliminated and this Cl will be linked to this particular Br, and hence you will have, I would suggest you, instead of this, add Br2 over here so that you can remember this. How you can remember this? That some student, someone out there was wearing some silver chain, right? Ag is silver, right? Silver chain. Some bad criminals, right? Br2 CCl4 it is basically, right? Some bad criminals, right? They will attack. What will happen? CO2 will be released. Ag will be released, right? Ag with Br, it will be precipitated out. And this CH3 will be linked to this Br. And hence you will have the formation of alkyl bromide. So these are the three naming reactions that can be directly asked to you, right? Okay. Next is preparation of aromatic halides. That is haloarenes, right? Okay. Okay, now let us see. Can you tell me what is the name of this particular compound? Everybody in the comment section, right? Okay, yes. Now what is the name of this compound? You have benzene, right? This we will see in the end of this lecture, how to prepare this, right? I want all of you to write down the name over here. Now, from this particular compound, so many different reactions are done. First is when you add Cu. Now, how to remember these reactions? Simple way. This is Sand-Mears reaction. Sand means salt. Sand has salt, right? So some kind of salt you will use, that is COCl, right? Cu, copper salt you have used here. If you are replacing this with Cl, then you will use salt of chlorine. If you are replacing this with Br, you will use salt of bromine, right? Next is Gattermann reaction. So what is a gutter? Gutter is a very smelly thing, right? So for gutter, whenever something is smelly, we need powder. So that's why we use copper powder, not the salt. That's the only difference here, right? So this is copper powder, this is copper salt, right? This is Sand-Mears, this is Gattermann. Otherwise, everything else is same over here, right? Next, very important, if you use Ki and vomit, you will have iodide over here, right? Very important reaction, that is with very good. This is called benzene disonium chloride. Very good. On benzene disonium chloride, when you add NaBH4, right, and you heat it, right, what you will get is, you will get fluorine, right? So it will be named as Bals-Schiemann reaction, right? Bals-Schiemann reaction. I'll tell you one more thing over here. If you add NaNO2 and copper couple, same thing will give you NO, nitrobenzene, right? This is the additional reaction. So these are the four very important reaction of disonium chloride, right? Okay. Next is, if you have, let's say, directly from benzene, how you will prepare, right? Directly from benzene, what is C6H6? That is benzene. Directly from benzene, for example, I am adding Cl2 FeCl3, directly chlorobenzene. I am adding Br2, this should be over here, this should be Br2 FeBr3, right? Directly you will have bromobenzene. If you add I2HiO3, directly you will have idobenzene. This is directly from the benzene, right? In the end, I'll also show you how previous year questions are being asked from all the reactions that I'm telling you, right? Understood this or not, everybody? Now, is there any doubt on this particular slide? Is there any doubt over here? Then let me know in the comment section if there is any doubt over here, right? Okay. Now, let us see reactions of alkyl halide, right? What is alkyl halide? Rx. Till now, we have done preparation of aryl and alkyl halides. Reactions are very simple, very easy. In the starting, you'll find it little tough, but throughout organic chemistry, you will find the same kind of reactions, right? Now, very important thing is that reaction first is dehydrohalogenation reaction, very important. That is, halogen will be taken out, hydrogen will be taken out, this double bond will shift here, and you will have the formation of alkene, that is dehydrohalogenation. Now, we have two things, right? One is aqueous KOH, other is alcoholic KOH. So, I'll tell you the simple answer here. If you have Rx, right, let's say you have KOH alcoholic, I'm talking about this particular statement only. You have KOH alcoholic. KOH alcoholic will cause elimination, that is dehydrohalogenation, and you will have the formation of alkene, right? Now, this is Cl that is taken out, and from this point, this H will be taken out, and hence you will have the formation of this double bond over here, right? That will be done. Now, if you must have added KOH aqueous here. There's a big difference in KOH aqueous and alcoholic. In alcoholic, you have elimination, right? From this carbon, so exactly what is happening here, from this carbon, chlorine is getting eliminated. From this carbon, hydrogen is getting eliminated, and you will have double bond over here, and this is the compound that is getting formed, right? Now, but with aqueous KOH, there is no elimination, there is substitution. So hence you will have the formation of CH3, CHOH, and this is CH3. That is why I told you that this aqueous QH and alcoholic QH is very, very important, because it's just one slight difference, right? And the product is totally changed, right? Okay, this is done. Next is reduction of alkyl halides. Now you have RX. When you reduce it in the presence of zinc HCl, directly you will have the formation of the same number of carbon. Hydrocarbon will be formed here, right? Okay, next. Next is simple reactions here. First is Friedel-Crafts reaction. So, Friedel-Crafts reaction. So, basically there are two types of reactions here. Friedel-Crafts acylation, alkylation. Here we have written acylation. Alkylation, where I'll also tell you acylation here. So, this is basically alkylation. This is alkylation, where CH3Cl and hydroCl, Cl3, right? What will happen here? This Cl will be taken out by this anhydrous Cl3, which is a Lewis acid. That is what will take out this Cl here, and hence you will have the formation of this kind of electrophile. These are electrophilic substitution reaction, where this CH3 positive electrophile is going to attack on this any position of the benzene, because all are symmetrical only, and you will have the formation of, what is this called? Anybody in the comment section? What is this called? Anybody in the comment section? Now, if you similarly, if you have benzene, right? You use CH3, C double bond O, Cl, and there is anhydrous Cl3. Same thing will happen here. Cl will be taken out, and you will have the formation of a electrophile, that is CH3, C double bond O, CH3, C double bond O. This is positive. This electrophile is going to attack here, and hence you will have the formation of C double bond O, CH3. That's it. This is called Friedel-Crafts acylation. This is called Friedel-Crafts. Very good. That is toluene. Shabash. Very good. That is called toluene. Right. Very good. Now, next is reaction of Grignard reagent. Right. Okay. One by one we'll see that. Grignard reagent. First is two kind of reaction we'll see for Grignard reagent. One is I would say how Grignard reagent is formed, right? Grignard reagent is a very fond of proton source, right? I'll tell you everything about Grignard reagent, just give me some time. So firstly, how Grignard reagent is prepared. You have any alkyl halide, you add some metal, that is Mg, and ether here, right? You will have the formation of this RMgX. X is halogen, R is the alkyl chain. Basically, that is called the Grignard reagent. Now, Grignard reagent is crazy for proton, right? It's totally like crazy for proton. Now, what will happen whenever Grignard reagent will say, hey, you will give me proton? Then it will be like, okay, I'll take out proton from you and I'll get converted to hydrocarbon. There can be any proton source. Now, water is a very good proton source. That is the reason H positive will be given here, and you will have the formation of CH4. That means whenever Grignard reagent you will always use dry ether here. This is the first reaction of Grignard reagent, right? Okay, others we will do in aldehyde ketones and carboxylic acid, right? Now let us see three reactions, that is Woods fatigue and fatigue reaction. All are similar. Just remember, Woods is alkyl, fatigue is aryl. Okay, Woods is I'll do, thank you. Very good, Aishu. Very good. Now, Woods is alkyl, fatigue is aryl. Whenever you have only Woods, you will use two alkyl halides, right? Now, sodium and X will be eliminated, right? You will eliminate 2 NaX and you will have the formation of double the alkyl chain. If you have Woods fatigue, one is alkyl, one is aryl. Alkyl, aryl, again same thing, and you will have the formation of R and attached to benzene ring. When you have fatigue, both the R parts are aryls. This is also aryl, this is also aryl. Same thing, Na sodium will take out the halogen and you will have the formation of diphenyl here. That is called biphenyl, right? Okay, so these are the three important reactions. Now let us see other reactions of aryl halide. Very important. Can you tell me what is the name of this particular reaction? Anybody in the comment section? Let us see. Anybody in the comment section, what is the name of this particular reaction? That is called Dow's process. Okay, what is the name of this reaction? Very, very important reaction. You will also see this reaction in Dow's process, you can write. You will also see this particular reaction in alcohol, phenols and ethers, right? Okay. Yes, beta, duration is going to be how much time we have done? 1 more hour. Okay. Now, this is chlorobenzene, right? Chlorobenzene, basically what you will do, because this question has also been asked, that why this bond is very difficult to break. Because of resonance, what will happen? It will have a double bond character. That is why it is very difficult to break this bond. It has partial double bond character. Right? That is why very high conditions are needed here. Those high conditions are 623 Kelvin temperature, 300 atmospheric pressure, right? And this Cl will be replaced by OH. That is done. Now, next is, ma'am, what if I attach some electron withdrawing group at ortho and para position? Very important point I'm telling you right now. At ortho and para position, if you attach electron withdrawing group, then the conditions are going to be less harsh. At para position, you have one NO2, then this is going to be 443 Kelvin. You have one ortho and one para position, two NO2 group. Conditions, see, here temperature is 623, here it is 443, it is even decreasing, 368. Now, at all the ortho and para position, you have electron withdrawing group. Now, you have just warm it and it will be getting converted to OH. Now, anybody, what is the name of this particular compound? Anybody? Dow's process, very good. What is the name of this particular compound? Everybody. The name of this particular compound is very, very important. Yes, I want to see that in the comment section. What is the name of this particular compound? Last is electrophilic substitution reaction. All are same. Okay, all are same. Very simple, very easy, very simple. Okay, you just need to understand one thing. I'll give you a simple trick to understand things, right? A very simple trick. Okay, you don't have to cram anything here. Just remember this particular thing. If you have a benzene ring that is attached to some group which has lone pairs, then it will show plus M effect. That means it will be ortho-para directing. All the electrophiles will be attached to ortho and para position. Para being the major. But if you have a benzene ring which is attached to a group which is double bondedly or triple bondedly attached to a more electronegative compound, it will show minus M effect. So it will be meta directing. That is why this particular, that is aryl halide, it is always going to be ortho-para directing because it has lone pairs over here. Right? Okay, so just this thing you need to remember. Very good. That is picric acid. Very good. This is picric acid, which is yellow in color. That you don't need to remember. Just remember this is picric acid. Okay. Now, all you need to remember is that this kind of compound will give you ortho-para directing groups. So, when you have Cl positive as the electrophile, this will, wait a minute, yes, that will give you ortho-para. That means over here and over here you will have the attachment. Para being the major product, always. This is ortho position, this is meta position, this is para position. OMP, O my Prabhu, okay? OMP, O my Prabhu, OMP, ortho, meta, para. That's it. Now, nitration will give you NO2 positive electrophile, right? This NO2 positive electrophile, again, it is going to attach on ortho and para position, para being the major product, right? Next is, you have sulfonation. Sulfonation, again, what we are going to do? We are going to add concentrated H2SO4. It is again going to give us ortho and para product, SO3H, and para being the major product. Fieder-Crafts reaction, alkylation, acylation. In alkylation, you have CH3 positive as the electrophile that is going to attack on ortho and para position, para being the major product. In acylation also, you will have this electrophile that will attach on ortho and para position, para being the major product, right? Then next is reaction with metals. Directly this reaction we have already done. Anybody, what is the name of this reaction? Woods fatigue reaction. We have already done fatigue reaction also. We have already done, right? Okay, understood. Yes, everybody. We have completed one chapter. Next is alcohol, phenols, and ethers. Okay. But before that, let me see how many of you have already liked this session and how many of you have subscribed to this channel, V Karnataka KCET and Boards, because we are doing a lot of you, a lot for you. Physics and mathematics has been done. Right now is the time for chemistry. Then there is bio. So stay tuned to this particular channel so that you can take every advantage that is provided to you for totally free of cost, right? So if you actually subscribe to the channel, only then you will get the notification, the community post, everything that is being notified to you, right? Otherwise you will stay in that loop that okay, a notification will come but you have not subscribed. So there is maybe you will miss out on some things that you need right now, right? Okay, now next is preparation of alcohols, right? Okay, next chapter, preparation of alcohols. I would say this is a medium priority chapter. So please focus on this chapter with full dedication. Definitely you will see some of the reactions are getting repeated again and again, and some reactions will be very new to you. So focus fully on this particular slide, right? So first is preparation directly from alkenes. First you will do the preparation from alkenes. So there are three things that you need to remember. One is by acid catalyzed hydration, very important. So in this, what exactly you will do? You will follow Markovnikov addition, or you can see firstly we will make carbocation which is stable, then we will rearrange it, then or you can just simply write Markovnikov addition. You will follow Markovnikov rule, right? In hydroboration oxidation, you will follow anti-Markovnikov rule. Anti-Markovnikov rule, these two things you need to remember, right? Okay, so here what exactly is happening? This double bond will break, but the negative part will go to the less number of hydrogens. So that means less number of hydrogen means here. So it is following Markovnikov addition. But hydroboration oxidation, that means when you add hydro, that is diborane, B2H6, and you oxidate, you do the oxidation here by adding H2O2, what will happen? You will follow anti-Markovnikov rule. That is, negative part will be attached to the more number of hydrogen. That means OH will be here and H will be here. Hence, the ending product is CH3, CH2, CH2OH, right? So it is an anti-Markovnikov product here. Next is from carbonyl compound, what you do. Carbonyl compound means when you have C double bond O, right? So let us see the reactions for carbonyl compounds. When you have C double bond O, this is aldehyde, this is ketone, right? So what you do, you just do the reduction here, H2PD, right? Catalytic reduction we are doing, you will get the alcohol. Now, when you have to convert aldehyde ketone to alcohol, you don't need to add very strong oxidizing agent, is not needed. Okay, oxidizing agent will work here. So you'll add PD, catalytic hydrogenation will work, or you add NaBH4, that will also work here. Next is by reduction of carboxylic acid and esters. Now, here you need to use very strong oxidizing agents, right? Because what is the chain? The chain is firstly you have alcohol, then you have aldehyde ketone, right? Then you have carboxylic acid. So to convert aldehyde ketone to carboxylic acid, there is just one step. But for COH2OH, there is two steps involved. That is why strong oxidizing agent like LiAlH4 or doing repeated oxidation is needed here, right? Next is from Grignard reagent, what you have to do. So this is a very important reaction that I will show you on the next page only. This you will do throughout entire organic chemistry, you will do the same thing, right? So what exactly you will have? Let's say you have R C double bond O and you have R dash. Whenever you have carbonyl compound, this is RMgX, right? Always remember, I'm giving you, I'm not making you cram these things. This is very important, okay? You need to understand this. This is always electropositive, this is electronegative. This is electronegative, electropositive. It will attack here, electrons will jump here. You will have RCO negative. This positive will attach here, MgX positive. This will be R dash, and here R has attacked here, this will be R. After adding water, this will get converted to OH. This is R dash, this is R, and this is R. That is how this full reaction is being done. Right? Okay. Yes, PDF will be provided to you. Don't worry about that. Right? Okay. Link will be in the description. That will be provided to you. Next is phenols. Now, the preparation of phenol is directly asked because all the reactions are very, very important for you. The first reaction that I would say that you have done is this Dow's process. That when you have, no, this is not Dow's process. Wait a minute. This is Dow's process, right? So, first is Dow's process when you have chlorobenzene at a very high conditions like 623 Kelvin temperature, high pressure, you will get the formation of phenols, right? Okay, when you add NaOH here, that is from chlorobenzene. This is the first reaction. Second is from, let's say you have, what is decarboxylation reaction? When you use soda lime means you use quicklime and you use caustic soda. That is NaOH and CO, soda lime decarboxylation. Simple, what will happen? This thing will be eliminated. You have NER and COONA is attached to it. That COONA will be eliminated and you will have the formation of rest of the product, that is phenol will be formed here. That is called soda lime decarboxylation reaction, right? This is also done. Next is cumene process, and it is a very, very important process, right? Here you will have isopropyl on the benzene. That is called cumene. This particular thing is called cumene. Okay, this is called cumene. Now on the cumene you add O2, right? Then you add H positive H2O. You will get the formation of phenol and you will also get the formation of acetone over here, right? And acetone. I'll just write it here. Phenol plus acetone, right? Why I have written phenol and acetone both? Because both the products are important for you. They can ask you what are the two byproducts in cumene process, right? This is also done. Next is, if you have simple, this rarely they ask this. This is being asked. This also very rarely. Okay, so mostly they ask either Dow's process, soda lime decarboxylation, cumene process, and disonium salt formation, right? Now here it is benzene sulfonation, right? Very rarely they will ask you this. NaOH you add, again fuse it with NaOH. You'll have the formation of sodium phenoxide. Then again add dilute HCl, then you will get phenol. Very rarely asked, right? Here it is from disonium salt. How disonium salt is formed? It is formed from aniline. Add NaNO2 HCl. This will be converted to N2Cl. And in this, very important, very, very important, you just add water and warm it. You will replace this N2Cl with OH. If you have simple, let's say alkyl disonium chloride, then you don't need to warm it. It will be directly converted to alcohol. But here you have benzene disonium, so you also need to warm it. Because this benzene disonium salt is stable between 0 to 5 degrees Celsius. Right? That's why we need to warm it. This is also done. Okay. Next is phenyl magnesium bromide. So simply, this is RMgX. Right? So whenever you have RMgX, you add O2 here. Right? This will be converted to OMgX, or you can say OMgBr. Then add H positive. This will be converted to phenol. This is also very rarely asked, right? So this is important. This is important. This is important. This is very, very important, right? Okay. Next is the reactions of phenols. Let us see the reactions of phenols, guys. Everybody, let us see the reactions of phenols, right? Now, anybody in the comment section, if you can tell me that whether phenol is ortho-para-directing or meta-directing. I want to see that in the comment section, right? I want to see that in the comment section, right? Okay. Yes. Samina, okay, I'll do that. Don't worry. Okay. After this, I'll just conclude that SN1, SN2 reaction for you, right? Okay. Now, this is phenol. It is always ortho-para-directing because this OHO has lone pairs over here. So, it is always ortho-para-directing. So, same way, firstly, let us talk about when you add Br2, right? And this is Br2 water. Very, very important this is. Br2 water will give you tri-substituted product. But Br2 in presence of CS2, that is a non-polar solvent, that will give you ortho and para product individually. That will not be a tri-substituted product. Same in case with concentrated HNO3 and dilute HNO3. When you have dilute HNO3, it will give you separate ortho-para products. But when you have concentrated HNO3, that will give you tri-substituted product of NO2, right? Now, ma'am, you said that always para is going to be major. But ma'am, here ortho is major. This is major reason. Because there will be hydrogen bonding between this. Whenever you have hydrogen bonding, definitely that is going to be the major product, right? Next is, if you have acylation, alkylation. For acylation, simply add ortho-para substituted, CH3 will be attached at ortho-para position, but para being the major product. Similarly, if you have acylation, wait a minute, acylation is not written here, but yes, if you have acylation, that will be COCH3 will be attached here, right? Okay. Now, there are some different reactions of phenols that you need to remember. One is when phenol is reacted with zinc dust, it will give you directly benzene. Phenol with zinc dust will give you benzene, right? This is also done. Phenol, when it is reacted with a very strong oxidizing agent, that is Na2Cr2O7, it will give you benzoquinone. Okay, it will give you benzoquinone, very, very important. Next is, if it is reacted with Na or NaOH, it will give you, just replace H with Na, that is sodium phenoxide, very simple reaction. Then with H2SO4, it will substitute this SO3H on the para position, para being the major product. Right, that was also simple. This is ours, this is ours, this is ours, this is ours, this one, this one, this one. All these are important. This one are not very important, right? Then what is this? And what is this? Very important reactions. This is called coal-base reaction. Coal-base reaction, right? So in coal-base reaction, you have phenol, you add NaOH, it will be converted to phenoxide, sodium phenoxide, right? After that, very important, you add CO2, 400 Kelvin, right? And you will get salicylic acid here. In coal-base reaction, you use CO2 and you get salicylic acid. But in Riemann-Tiemer reaction, you use CHCl3, aqueous NaOH, and you get salicyl aldehyde. Okay, not acid, right? Okay, so these two are very, very important two naming reactions, right? Then there is when you add H2 in presence of a catalyst, all the double bonds are will break and you will have the formation of cyclohexane, right? And you will have OH over there, right? Okay, so this is full mechanism also of coal-base reaction. So what exactly happens in coal-base reaction, right? This is Riemann-Tiemer reaction, right? Now let us see test for phenols, right? So there is two tests, that is ferric chloride test. So simply remember one thing. If you have ferric chloride test, it will give you phenol with FeCl3 will give you violet complex. That's it. Just remember it will give you violet complex. That is done. With bromine water, it will give you tri-substituted product which is having white precipitate. So whenever there is some test, that will give you like visualization that what color change, what odor, everything will be given to you, right? Okay. Next we have preparation of ether. Last part of this chapter, preparation of ethers, right? Let us see the preparation of ethers, right? Which one, Telugu, which one you want me to repeat? Okay, preparation of ethers, very, very important that if you have, this is Rx, this is R-ONA, right? This is called Williamson synthesis reaction, where this X and Na is going to eliminate and you will have the formation of R-OR. This is called Williamson synthesis reaction. Very important thing about Williamson synthesis reaction is that it can be used to prepare ether containing 2 degree or 3 degree alkyl groups through SN2 mechanism. In this case, the alkyl halide, very, very important. This is the most important line of Williamson synthesis reaction, that alkyl halide must be 1 degree primary, right? In case of 2 degree, 3 degree alkyl halide, this reaction will not take place, right? Okay. Now, from alcohols by dehydration, basically two things are there. If you have temperature, that is 413, then two alcohols, so this is ROH, ROH, okay. When the temperature is 413 Kelvin, this will be eliminated and you will have the formation of ROR. Otherwise, when you have alcohol, by elimination, it can also form alkene, depending upon the temperature. If temperature is 443, it will eliminate and give you alkene. But if the temperature is 413, it will give you ether. This is very, very important, that it depends on the temperature, right? Okay. This is the detailed part of Williamson synthesis reaction. One example, right? So here you have 1 degree alkyl halide. That is why this reaction will give you ether, right? Okay. Yes, everybody. Now, this is the reaction. One by one, we will see that. Okay. Yes. Now, cleavage of CO bond in ethers. Everything we'll do here, right? First is this reaction of HX. What will happen with the reaction of HX? What exactly will happen? This is H positive, this is negative. So what will happen? X negative will attach to either of these alkyl chains, right? So always make a stable alkyl halide, right? So if you have, for example, if you have this benzene O and R, this X negative will be attached to this O and H will be attached here. Sorry. H will be attached here and X will be attached here. Because phenol is a more stable compound, right? Okay, that is done. Now, very, very important part, that whenever you have, let's say you have HX, this is a compound. Now, here you have a question that whether halide is attached here or halide is attached here. Always remember that 3 degree alkyl halide, if any of the alkyl chain has 3 degree alkyl halide, if any this one or this one is 3 degree, any of this is 3 degree, then alkyl halide that will be formed will be 3 degree. That is why 3 degree alkyl halide is formed here. Understood? Yes. Understood? This is a very, very important, very, 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 very important reaction. This is also a very important reaction, that phenol will be formed if you have to choose. And here, if any of the side chain is 3 degree, then 3 degree alkyl halide will be formed. Understood? Is that clear? Is that clear or not? Is that clear or not? Okay. Understood? This is a very, very important point, guys. Right? Okay. If this is not clear, then let me know in the comment section. Okay. Next is electrophilic substitution, halogenation, Friedel-Crafts reaction, all these things, same copy paste that we did for phenol. Ortho para product will be formed, para being the major, para being the major, para being the major, right? Para being the major, right? Nitration is having NO2 positive, acylation is having CH3CO, alkylation is CH3, halogenation is Cl or X positive, right? So same thing is copy pasted here, right? Okay. Now before going to the third chapter, that is aldehyde and ketones, let me show you the difference of SN1 and SN2 reactions here. Right, SN1 and SN2. So I'll just differentiate. Same thing you will write in your exam. Let's say this is SN1 reaction, this is SN2 reaction. Okay. Basically, why it is 1 and 2? Because it is unimolecular, it is bimolecular in the rate of reaction. Right. 1 means it is 2-step reaction. How to remember? This is 2 means it is a 1-step reaction. Okay. 2-step means what will happen? Let's say you have, this is C, this is H, this is H, this is H, this is X. So what will happen? Firstly, you will have the formation of carbocation, right? After that, nucleophile will be added here. Then you will have the formation of this other product, right? So in this case, in this case, can I just directly write here? This is CH3X, right? Now, because this is a carbocation, so the nucleophile has only the possibility of attacking from this side. It cannot attack from this side, not possible. It only has a possibility of attacking from this side. That is why there is inversion product. I would wait a minute. This is OH, na? This should be OH here. Okay. Here only the retention product is formed. Okay. Only the retention product is formed. Right. Because only possibility of attacking is this one. Right. Now let us talk about the other thing, that is SN2. That is a one step. Here transition state is formed. So basically what will happen over here? You have, let's say you have C. This is OH, this is H, this is H, this is H. I am forming a proper shapes here, tetrahedral shape. What will happen? This is a loyal person, this is not a loyal person. Here, it will firstly break up with this OH, then it will add some nucleophile in place of this OH, right? But in this case, breakup has not happened, but nucleophile will get added here, right? So what will happen in this step? What will happen? You will have the formation of this kind of thing. Here OH is getting, it will break, and X is getting added here. Okay, X is getting added, or whatever you want to add here, that will be done, right? Now in this case, what will happen? Either it can attack from this side, or this X negative can attack from this side. Now what will happen? You will have the formation of retention. Retention means when it is attacking from the same side that there was OH, right? Inversion means opposite attack can be there, right? So this is overall summary of SN1, SN2, one step, two step. Here it is only dependent on the, I would say, substrate. This is dependent on both the substrate and the nucleophile. That is why it is SN2 reaction, bimolecular reaction. Okay, is that clear? Is that clear? Now next. Everybody, if there is any problem, then let me know in the comment section. If there is any problem, any sort of problem here, right? Now let us start with aldehyde ketones and carboxylic acid. Okay, let us start with aldehyde ketones and carboxylic acid. Right? Retention spelling wrong. Okay, I'll just correct the retention spelling. Retention. Okay, retention. Okay, now students, shall we move towards aldehyde ketones? That is the third chapter of organic chemistry. Right? Okay. Now, preparation of aldehyde and ketones. Right? If you talk about aldehyde and ketones here, oxidation of alcohol. Right? First is oxidation of alcohol. Right? So, if you want to convert alcohol to aldehyde and ketone, you need to use a good oxidizing agent, not a very strong oxidizing agent. Right? So, here, use oxidizing agent like K2Cr2O7, right? Here, this is being converted to, see, this is 1 degree. 1 degree alcohol gets converted to aldehyde. 2 degree alcohol gets converted to ketone. This is very, very important, that 1 degree to aldehyde, 2 degree to ketone, right? Next is catalytic dehydrogenation of alcohol. So basically what will happen, very, very important. But I'll just give you one simple thing here. That is, this is 1 degree. I'm just making one chart over here so that you don't need to cram anything here, right? 1 degree alcohol, 2 degree alcohol, 3 degree alcohol, right? Okay. I'll just use it over here. And one more double line, okay? Now, if you have mild oxidizing agent, you have strong oxidizing agent, you have copper, right? 3 things that they can ask you in the exam. 1 degree will give you aldehyde, 2 degree will give you ketone, 3 degree there is no reaction. Strong 1 degree will give you carboxylic acid, 2 degree will give you ketone only, 3 degree will have no reaction. Copper at 573 Kelvin is different. For 1 degree, 2 degree, it behaves like a mild oxidizing agent only, that it will give you aldehyde and here it will give you ketone. But with 3 degree, that is tertiary alcohols, it will give you, anybody in the comment section, anybody, it will give you, very, very important, it will give you alkene. It will give you alkene. This is very, very important, right? So just remember this chart. You don't need to remember all of this, okay? Just remember this chart. You don't need to remember all of this, right? Strong oxidizing agents like KMnO4, strong oxidizing agent, right? Jones reagent is a strong oxidizing agent. Mild oxidizing agents like PCC, PDC, right? These are mild oxidizing agents, okay? Yes. Now, let us see ozonolysis here. Reactions of, basically we are talking about how to prepare aldehydes and ketones. So how to do ozonolysis? With ozonolysis, simple trick is break the double bond, attach double bond here, attach double bond here, right? This is what you will get. This will be RC double bond OH. This will be RC double bond OH. That is the last part, that is RCHO you will get here, right? So that is reductive ozonolysis when you have zinc. But if you have oxidative ozonolysis, what will happen? Let's say we have this is C double bond O. Let's say this is CH3. I'm just doing simple random things here. CH3, let's say this is also CH3. If you have oxidative ozonolysis, you just need to break this double bond, attach double bond O here. This is CH3, this is CH3, plus this is C double bond O, this is CH3, this is H. Break the double bond O, break the double bond, attach double bond O. They will give you mostly reductive ozonolysis only. So you don't need to worry about what is the next step, right? Mostly this will be the answer, but by chance, if they have given H2O2, if they have given oxidative ozonolysis, what you will do? Just replace the hydrogen that is directly attached to the carbon. Just replace this hydrogen with OH. That is C double bond O. This is, all the hydrogens will be same. Just this hydrogen will be replaced here. Everything else. Here there is no hydrogen that is directly attached to the carbon, so it will remain the same. So C double bond O, this is CH3, this is CH3. So that is oxidative ozonolysis. If there is any problem here, then let me know in the comment section. In a very simpler way, I have taught you this. Right? Okay, this is done. Now, next is Rosenmund reduction, where you use Lindlar's catalyst. That is, you use basically hydrogenation only, but in presence of a poison like BaSO4 to reduce the rate here. So RCOCl is converted to RCHO in Rosenmund reduction. Very, very important, right? Next is reduction of nitriles. So if you have RCN, what you do? If you use ALHIBU, right? That is basically it is isobutyl twice. So this will be converted to RCHO. If you use Grignard reagent, that will be converted to RCOCl. If you use SnCl2 with ether and water, it will be again converted to aldehydes, right? Now, next is, if you have from esters, if you have Dibbel, right, then directly this ester is directly converted to aldehyde. But I'll tell you what are this is not very important. This is also not very important, right? This is important because this is a Stephen's reduction. This I would not say not important. This particular step, this particular reaction is important here. This reaction is important, right? This is not important. You can skip that. You can skip this also. You can skip. But this is very important. This is also very, very important. Ozonolysis is also very, very important. So I'm telling you side by side that what you can skip, what you should not skip, right? Okay. Next is Getterman-Koch reaction. Very, very important. Here you have benzene. You add COHCl, right? anhydrous ClCl3, directly benzene is converted to benzaldehyde. Next is Friedel-Crafts acylation, right? So basically here if you have RCOCl, this RC double bond O positive electrophile will attack here and you will have the formation of ketone, right? From alkynes, what you need to do? You have triple bond here. You add dilute H2SO4, it will be directly converted to aldehyde or ketone, right? Or you add, do hydroboration oxidation, then also you will get the formation of aldehyde or ketone. But this is also not very important for your PUC board exams, right? Okay. Next is very, very interesting. Again, this is all aldehyde and ketones what we are doing, because aldehyde and ketones is the most important chapter of your organic chemistry, right? Most important chapter. You really need to focus on this, right? Now, here it is. If you have oxidation of 1,2-glycol, right? What you will have here is that you have RCHOH, this is CHOH and R dash. You add lead acetate here, tetraacetate here, you will have the formation of RCHO. This is R dash CHO. This bond will break. Here you will have double bond, double bond. That means two aldehydes are formed when you add lead tetraacetate in vicinal, I would say, in the diols, right? Now, this is done. Now, again, we are doing one more thing. If instead of this, you just do oxidation, this is nascent oxidation, you just add oxidation, do oxidation, either add KMNO4, something like that. These are also diols. Again, this bond will break, this will be converted to double bond, this will also be converted to double bond, right? And hence you have the formation of two ketones, right? Now, next is Itard's reaction. When you have toluene, you add chromyl chloride, that is Cr2O2Cl2. Directly this CH3 will be replaced by CHO, that is benzaldehyde, right? Last is side chain chlorination. Side chain chlorination means you add Cl2 in the presence of sunlight. What will happen? Basically, eventually what will happen, this CHCl2 will be added here. It will be converted to CHCl2. After adding water, this will be converted to CHO, right? So basically what is happening here, this is benzene. What is happening here, this is benzene, right? Here you have CH3, this is CH, it is converted to CHCl2. When you add water, this is converted to OH and this is also to OH. Then this OH will eliminate, this H will eliminate, this double bond will shift here, and hence this basically this double bond, this bond will shift here, and hence you will have the formation of benzene, and this is C double bond OH. That is how we are saying by side chain reaction also you can have the formation of benzaldehyde, right? Okay, understood, right? Okay, next is reaction of aldehyde and ketones. Those were the preparations. Now we are doing the reactions of aldehydes and ketones, right? Now, very important, if you add HCN here, you will have the formation of cyanohydrine, right? So basically what will happen, this negative part, this is the positive part. Negative part will attack here, electrons will jump here. Here you will have the attachment of CN. Double bond will shift here, here it will be single bond, and here you will have the formation of OH. So this thing is called cyanohydrine, right? Next is same with this thing, that is NaHCO3, you add here. Then this SO3Na, that is attached, SO3Na, that is attached to this carbonyl carbon. Electrons will jump here, H is attached here, right? So bisulfite is formed. Out of this reaction is important, this reaction is not so important, right? This has never been asked, so that's why I'm saying this is important to you, right? Then you have Grignard reagent. This reaction we have already done, right? How this is negative, this is positive, negative will attack here, positive will attach over here, that is MgX, then that is converted to OH. So this thing will be formed, right? This is very, very important. This is the most important reaction. Grignard reagent with carbonyl compound is a very, very important reaction. Okay, it's a very, very important reaction. Then beta, this is hemiacetyl acetyl, this is ketal. How this is formed? Let us see that. So if you have on the ketonic part, on the carbonyl part, you add ROH and dry HCl. Dry HCl. What will happen? You will have the formation of hemiacetyl. Hemiacetyl means on carbon you have one OR and one is OH. Then again you do the same thing, right? Then this OH is converted to OR, that is called acetyl. Okay, directly this question can be asked. Next is you have, this is the carbonyl compound, this is CH2H, this is CH2OH, right? Ethyl glycol you are using, right? Here what will happen? This O and this H2, this thing will be eliminated. Let's say this is 2H and one O here, this is eliminated, this is carbon, one bond, other bond. These two bonds are, it were like this, now we have separated them like this. It was like this, we have separated them like this. Now, rest of the part, that is this O and this CH2, this O and this CH2, which are linked together, they are being attached here. That is called ketal, right? So, there is a formation of ketal here, right? This is also a protecting group because it is protecting this C double bond O, right? Okay. Last one, very, 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 very important reaction. Okay, let us see what is that important reaction. Beta, here you have C double bond O, right? I am saying that directly I will tell you simple thing here, that is you have C double bond O. If you have NH2Z here, NH2Z, these two things will be eliminated. You will have the formation of C double bond O, NZ, this thing, right? Now this Z can be anything. Z can be alkyl or aryl. This can be OH, this can be NH2, NHC6H5, this can be this 2,4-DNP, this can be NHCOCH3, different thing can be this Z. Depending upon that, you will have different answers here. Now, I'll send you a table on the Telegram channel. If you don't know the Telegram channel, it will be added on the description box, right? V Karnataka, KCET and Boards, that is a Telegram channel. I'll send you one table in the Telegram channel where you will get to know that if you use this particular Z, what will be the name of the product, right? Okay, that I'll send on the Telegram channel, right? Okay. Now, next is this reactions of aldehyde and ketones, right? Next part is if you have basically oxidation, tolerance reagent, all these things, Felling test, all these things we are talking about here, right? Okay. Yes. Okay. 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 Now, here it is ketone. I think I just need water, but I don't have that here. Chalo, no worries. This is RCO, R dash, that is ketone. Ketone, when you add K2Cr2O7, a strong oxidizing agent, that is directly converted to carboxylic acid, right? When you add tolerance reagent, which gives positive test only for aldehyde and only for aldehyde, whether it's aliphatic or it's aromatic, right? Felling test will give positive test only for aliphatic aldehydes, not for aromatic aldehydes, right? Okay. Benedict test is same as Felling. It's just that Felling can be stored and Benedict is prepared. Benedict you can prepare it freshly, right? No, sorry, Felling cannot be stored and Benedict can be stored. That is the only difference. Here you use a tartrate, here you use citrate. So there are two things. So basically in tolerance test you have silver mirror. So you use silver nitrate solution here. In Felling test, you use Felling A and Felling B solution. Felling A is your simple tartrate, right? Sodium acid of tartrate, right? But Felling B is copper sulfate solution. Okay, so that is why you have Cu2 positive ions here, right? So similarly here in this case you have sodium citrate, and sodium tartrate is called Rochelle salt, right? So these are few important things for the tests, right? Here you just say both the aldehyde, this is only for aliphatic aldehyde. This is also only for aliphatic aldehyde. Okay. Next is, if you have, let's say, same thing, you are adding hydrogen in the catalytic way. Directly, you will have the formation of alcohols. Or you're adding LiAlH4 or NaBH4, that are good reducing agents, you will have the formation of alcohols, right? But very important thing is, if you are using zinc amalgam with HCl, that is Clemmenzian reduction, that will directly, this double bond O is converted to H2, right? Directly to the hydrocarbon. Same way, if you use hydrazine in presence of basic conditions, that is KOH, that is called Wolff-Kishner reduction. Same product, that is this double bond O is converted to H2. And if you use HI in presence of red phosphorus, it will give you the same answer, that is double bond O is converted to H2. So these three reactions are very, very, very important, right? Okay, these three reactions are very important. These three reactions are also very important, right? These three tests and these three reactions are very, very important, right? Okay, now next is aldol condensation. What is aldol condensation? Simply I'll tell you how do you do aldol condensation. First thing is, for this you need to have alpha hydrogen present, right, on the aldehyde or the ketone. Now, I'll take one example here, that is CH3CH2. Okay, I'll just use this example to make you understand what is there. CH3CHO. Right. So, what you have to do, take two reactants, right, CH3CHO. Take two molecules of it. One molecule, expand the C double bond O, right? In the fully form, write C double bond O. In the other part, write down the alpha carbon. This is alpha carbon. This is CH2. Write down hydrogen in a different form, right? In one compound, in one molecule, write down C double bond O. In other molecule, write down the alpha hydrogen, right? Once you have done that, just give me a second. Once you have done that, then what you have to do? Once you have done that, then what you have to do? Simply, this is done, right? Then how products will be formed? This is CH3, this is C, right? What you need to understand, that alpha hydrogen will be taken out. It will be placed on this carbonyl carbon. So this is carbon. Here you will have the formation of this alpha hydrogen will be pasted over here, right? And attach the carbonyl carbon with the alpha carbon. So attachment will be there. This will be CH2. This is CHO, right? This is aldol product. After that, eliminate water, that is condensation. Hydrogen will be eliminated here, OH will be eliminated, and hence you will have the formation of, this is CH3, this is C double bond, this is CH, this is CHO. That will be formed. Any problem here, guys? Any problem here or not? Right? Okay? Understood or not? Should I repeat it? You will just have two molecules. This is self-aldol, right? Write down two molecules in different ways. Here expand the, write in the full form, right? C double bond O. Here write down properly the alpha hydrogen. Now what you have to do, attach this carbonyl carbon with the alpha carbon of the other molecule. This hydrogen is placed here. That's it. Join these two, then eliminate water, and answer will be there, right? Okay, is that clear to everybody or not? That is aldol condensation, right? What is This is aldol condensation. Why I did that? This is the full mechanism. That base firstly will take out the alpha hydrogen. That is why this negative part that will be formed here. Then it will attack on the carbonyl carbon and hence you will have the answer. Right? Okay, so I have given you a short trick for that. Now, cross aldol condensation when you have two different products. Same thing you will apply here. It's just that if you have, let's say, two molecules here, firstly this CH3CHO will itself do self-aldol. It will give you one product. Then this propanol will give self-aldol product. That is the second product. Two products will be there. Then two products will be of cross-aldol. That is, this CH3, in one product you will have CH3 C double bond OH plus you will use the alpha of this one. You will use the carbonyl of this one and alpha of this one, right? Then you will have one more product where you will use carbonyl of this one and alpha of this one. You will attach both of them. So that's how you will get four products, right, in the end. Got it? Yes. Now, next is cross-aldol. Okay, this is not cross-aldol. Wait a minute. Okay, so now ketones can also be used as one component in the cross-aldol reaction. So basically, this is what they are saying. Now here what we are doing, one is not having alpha hydrogen, other is having alpha hydrogen. So is there any choice that you are left with? This is not having alpha hydrogen, so you just write it C double bond OH. And here you have alpha hydrogen, so this you can write CH2, this is H. So you can just add these two things. How? This is benzene, this is C. Carbonyl carbon, right? Attach this carbonyl carbon to the alpha carbon. This is C. This is converted to OH because this hydrogen is shifting here. This is attached to the CH2 here. This is CO. This is benzene. That is how you will get the full-fledged answer here. After that, eliminate COH and CH2 and this is what you will get. Right? This is what you will get here. Understood? Is there any problem here? Okay. Next is Cannizzaro. Cannizzaro is quite simple. That is when you don't have alpha hydrogen. So it is quite simple. One product will be oxidized, one will be reduction product. That is disproportionation. So you have let's say you have formaldehyde. One will be oxidized to carboxylic acid salt. Other will be reduced to the alcohol with the same number of carbon. Same with this one. One will be oxidized to the salt of carboxylic acid. Other will be reduced to the alcohol. Right? So that is Cannizzaro reaction. Right? Okay. Now, next is preparation of carboxylic acid. Let's see the preparation of carboxylic acid here. Okay. Till now, most of the things, guys, we have done. Let me know in the comment section if you're able to understand this. Right? Okay. That is very, very important for you to know. Right? Okay. Yes, everybody. Shashank, Sanjeev, Pradeep, Sani, Aishu, Bhuji. Yes. Okay, let us see that preparation of carboxylic acid. Right, what is the preparation of carboxylic acid? Let us see that. So, carboxylic acid can be prepared by different methods. One is if you have primary alcohol, you use very strong oxidizing agent, then you can easily prepare carboxylic acid. Other is you have aldehyde, you use good oxidizing agent, directly carboxylic acid can be prepared. From aldehyde, right, you use Fehling solution, you use Tollens solution, you use mild oxidizing agent also, you can easily prepare the carboxylic acid, right. These two are done. Next is if you have let's say nitriles, okay, then you have to use strong mineral acid so that you form carboxylic acid here. If you have Grignard reagent, if you use carbon dioxide, this is a very, very important reaction. This is a very, very important reaction. I'll just show you how. Okay. So this is a very, very important reaction. That is, you have C double bond O, carbon dioxide. This is RMgX. Okay. Here, This is negative, this is positive. Negative will be attacked here, electrons will jump here, right? And then you will have C, this is double bond O, this is O negative, electrons are jumping here, this is R, right? And here this O negative is attached to MgX. After the hydrolysis, this OMgX is converted to OH, right? And this is the carboxylic acid that you will form, that is C double bond OH, COH, right? So that becomes a very, very important reaction, right? Okay, I'm also telling you what you need to focus. If I'm saying this is important, this is very important, right? Then you have RCOH, right? After the hydrolysis, you will have the formation of, opposite I am saying. If you have, let's say amide, that is CONH2. Then after the hydrolysis, basically amide is C double bond O NH2. This NH2 is directly converted to OH after the hydrolysis, right? Now, if you have RCOCl, again you add water, right? In the acidic condition, this Cl is replaced by OH, right? If you have acid anhydride, again you add water. These are all hydrolysis reaction of ester, right? So what you have to do, just break the Cl bond here, break the CO bond here, then this is converted to COH. Okay, so if you have ester, again what will happen, you add water here, this bond will break and hence you will have the formation of RCOH, right? Then if you have alkene or alkyne, do the oxidation, then this will be converted to carboxylic acid. These are all very, very simple reactions, right? If I would say just go through them, do these reactions in detail. These reactions, just remember that carboxylic acid can be prepared from RCOCl, acid anhydride, ester by hydrolysis. Just remember this line. And for alkene and alkyne, you need to use very strong oxidizing agent like KMnO4 in the basic condition. Just remember this, right? This is a very, very important reaction. That is, if you have any alkyl group attached on the benzene ring, that alkyl group can be anything. It can have 3 carbon, 4 carbon, 2 carbon, 1 carbon, 10 carbon, 20 carbon, doesn't matter. This, if you use KMnO4, any good oxidizing agent you are using, then this whole alkyl group is converted to COH. This is a very, very important reaction, that it doesn't matter how long is the alkyl chain, it will get converted to COH, right? Okay. Okay, students. Now, next is reaction of carboxylic acids, right, involving cleavage of OH bond, right? So that is basically involving cleavage of OH bond basically here. That means this bond we will break, right? So if you use Na, if you use NaOH, if you use Na2CO3, if you use NaHCO3, what will happen? This H will be replaced by Na. That is all we have done here, right? Next is reaction involving cleavage of COH. That means C double bond. This bond we will break. How this bond we can break? If you use, let's say you use P2O5, you add here H positive and you heat it, right? So what will happen? This bond will break, right? This bond will break and hence you will have the formation of anhydride, right? So basically what we are doing here, that this is R C double bond O, this is OH, this is again R C double bond O, this is OH. Here this bond will break, here this bond will break and hence you will have the formation of acid anhydride. This is what we are saying here, right? Okay. Now next is, if you have, let's say with acid you are adding alcohol, that means ester is being formed here. So this bond will break. Here this is ROH, this bond will break and hence you will have the formation of RCOOR, that is ester is formed. This is esterification reaction, right? This question also they ask you in carboxylic acid, which bond will break? In esterification reaction, C double bond O, this CO bond will break. That is the single bond that will break, Then if you add PCl3, if you add PCl5, directly this OH is replaced by the Cl. Okay, directly that thing is formed. If you have NH3 and you heat it, directly this OH is replaced by NH2, that is amide is formed. So these are the reaction involving breakage of COH, right, that bond. Now next is reaction involving this bond breakage, that is very high conditions. This bond will break. So if you have very strong reducing agent in presence of ether, or you add B2H6 ether and you hydrolyze this, then what will happen? Directly this bond will break, right, and hence you will have the formation of, this is basically RCH2OH, like reduction is happening here. And if you add NaOH, this is the soda lime decarboxylation that I was telling you, that in this case this CO2 will be eliminated and hence in the end you will have the formation of RH, that is soda lime decarboxylation reaction, right? Okay, this out of this page, this reaction is very important, this reaction is important, this is very important, this is also very important, this is very important. These are same reactions only, so you just go through this one. So out of 1, 2, 3, 4, these 5 reactions are important on this page, right? Okay, chalo. Reactions of carboxylic acid, let us see that. Reactions of carboxylic acids. So first is very, very important, that is Helmholtz-Zielinski reaction, right? HVZ reaction. Here what we need to do, this alpha carbon, the alpha hydrogen will be replaced by the halogen that you will add here. Let's say you're adding Cl2, then Cl will be replaced. You are adding Br2, then Br will be replaced. That is Helmholtz-Zielinski reaction. Okay. Next is for the detection of carboxylic acid, when you add NaHCO3, then brisk effervescence of carbon dioxide is eliminated if there is carboxylic acid present here, right? And with FeCl3, buff colored precipitates are formed, but with phenol, violet color precipitates are formed, right? Okay. Next is the last chapter of today, that is amines, right? Biomolecules I am not going to do today. Why? Biomolecules, guys, I'll do that. Biomolecules, I'll do that today only, but at 6 p.m. lecture, because inorganic chemistry has only 2 chapters, right? So it will hardly take us 40 minutes, right, to complete inorganic chemistry. Rest of the time for inorganic chemistry I'll give to biomolecules, right? Organic chemistry is itself very big, right? So that's why biomolecules I'll keep it to the inorganic part, because inorganic part has a lot of things to learn also. So that's why biomolecules I have kept it in the inorganic part of today's lecture, right? Okay. Now this page is very, very important for you. Very, very important, right? Okay. Why? First is how RNH2 is prepared from Gabriel phthalimide, Hoffman bromamide degradation. In Gabriel phthalimide, you have this phthalimide, right? And you add KOH, what will happen? In KOH, this H is replaced by K. When you add R, this is replaced by R. After that, you add H positive, OH negative, you hydrolyze this. This bond will break, this bond will break. Here you will have H, here you will have H. That is RNH2 is formed as the final product, that is called Gabriel phthalimide reaction. Very, very important. Directly this can be asked. Hoffman bromamide degradation, again a very, very frequently asked question for your PU board. That is RCONH2, right? Add Br2KOH. What will happen? This CO will be vanished off and you will have the formation of RNH2, that is Hoffman bromamide degradation reaction, right? Then if you have RNH2, right? Here you add SnHCl or FeCN because these are Stephan reduction, right? So this NO2 is converted to NH2, right? Then Hoffman ammonolysis, that means to the alkyl halide, you add ammonia 4 times. First time you will get 1 degree, second time you will get 2 degree, third time you will get 3 degree, fourth time you will get quaternary salt, right? Next is Mendius reduction. where you have RCN, and here when you're using sodium amalgam and ethanol, right, directly you will have the formation of RNH2, right? So basically why this is so important, here you have R plus 1 number of carbon. Here you have only R number of carbon. That means if you have a nitrile which is, let's say, having 10 number of carbon, then in this you will have 9 number of carbon. So that is why Mende's reduction is important, right? In simple, you have NO2, same number of carbon. Here it is reduced. Reduction of amide. So these two things are quite, you can get confused here. Here you have RCONH2, but with the simple reduction, what you will get this double bond O is converted to, let's say you have R, this is R, C double bond O, this is NH2. Here this double bond O is converted to CH2. With the same number of carbon, you have amine. But here, this CO is not getting reduced. This is getting eliminated. That is Hofmann-Bromamide degradation. That is why these two things are important for you. Right? Okay, when you have same number of carbon, here you have less number of carbon. Right? Okay. Now, Gabriel phthalimide in detail. Right? I have already told you what will happen here. Right? That firstly, K positive is replaced, then R is replaced, then this bond will break, and hence you will have the formation of 1 degree amide. Right? Hofmann-Bromamide degradation. This also I have shown you how this will be done. Right? Okay. Next is reaction of amines. Reaction of amines. This is RNH2. Very simple thing we will do here. Right? Very simple thing. Very, very simple thing. Reactions of amines. That is RNH2. But I am telling all the important reactions only. Right? That's why you will see the PDF. I have written some important concepts there. Now, very important, how amines react. This is RNH2, right? Firstly, let us go through the Hinsberg test. Okay, Hinsberg test, or I'll do that after, right? Firstly, go through all the important reactions. That is, if you add HNO2 here, this is diazotization. Either they can write HNO2 or they can write NaNO2 plus HCl. Both are the same things. Right? Here, what will happen? The first step is this will be converted to, the first step is it is converted to RN2Cl. As I told you that alkyl diazonium chloride is not at all stable, so directly it will be converted to ROH. Important reaction, right? Then very, very, very important reaction, that is carbylamine test, isocyanide test, right? Carbylamine test, isocyanide test. Here what will happen? You have R, right? This is RNH2. It will give you isocyanide, that is foul smelling, right? Here you will use same reagents that you have used in the Riemer-Tiemer reaction, that is CH3Cl aqueous alcoholic QH. So you'll have the formation of RNC, right? Then if you add these two reactions are important, then there is Hinsberg test, right? Hinsberg test, let us see Hinsberg test here. Very, very important. The test of to distinguish between 1 degree, 2 degree, 3 degree. Remember that carbylamine test is only for primary amines. Remember this. And remember that Gabriel phthalimide reaction. Wait a minute. Remember that Gabriel phthalimide reaction is only for the preparation of 1 degree amine. Okay. Now, let us move ahead. Here it is for primary, secondary and tertiary. If you have, let's say, primary amine, then it will give you, basically what will happen, this HCl will be eliminated and you will have that product which is having one hydrogen, that is why it is soluble in alkali. With 2 degree amines where 2 alkyl chains are attached, it will give you that particular answer. It will give you that particular answer which is insoluble in the alkali, right? It is insoluble in the alkali. With 3 degree, there is no reaction. I'll just write it here. 3 degree, no reaction. Okay. Now Next is some very important reaction of arylamines. Very important. Let us see that. We are just left with 2-3 more charts here and we will be done with organic chemistry. Right? This is aniline. Now, very important thing here. Br2 and H2. Now tell me whether it's orthopara directing or not. It has lone pairs on nitrogen, so definitely it is orthopara directing. So when you add Br2, it will give you tri-substituted product, right? Now, very important thing is that, wait a minute. Acha, this to we have done, na? Acha, if you want to get a para-substituted product, you don't want to get tri-substituted product, you only want to get mono-substituted product. What you will do here, you will do the acetylation. Let me see if it is okay, it is not written there. So I'll just write it here. If you want to get para-substituted product or you want to get just simple mono-substituted product, you will firstly attack this with CH3. I'll just write it here. This we will use in nitration also. This is aniline. This thing is called acetylation. You can either use COCl or acid anhydride. Anything you can use here. This is NH, C double bond O, Cl, CH3. Right? After that, you do the bromination. Then you will get mono-substituted product. This is NH, COCH3. This is Br. Then you add water. You will get mono-substituted aniline. Right? Same is with the nitration. Right? So basically, same is with the nitration. Here, this is what I have told you, that first you add CHCl3, then you add, or you can also add anhydride, then you add Br2, and with the help of acid, you will get this particular thing. This also we have done. Now, when you do simple nitration, what will happen? You will always get meta product also. But you will say, ma'am, aniline is not meta directing. Aniline is not meta directing. So what exactly happens? This anilines, in the acidic condition, it gets converted to anilinium ion, which is meta directing. That is why, if you don't want to get the meta product, you only want to get para product, you have to repeat this thing. That is, firstly, you will do acetylation, right? That is NHCOCH3. You will protect the aniline group here. Now, this group is being protected. Now, you add NO2. You do nitration now. This is NHCOCH3. This will be NO2. After that, you again add water and acid. Now, this whole product is getting converted to NH2 and this is NO2. Right? That's how you can avoid meta product. And this question is very important. Right? This also we have done. This is CH3Cl3. This is nothing but this is carbylamine test, isocyanide test, right? Where you'll get, instead of NH2, you will get NC, isocyanide, foul smelling. Here, if you add K2Cr2O7 directly, just like in the case of phenols, we got benzoquinone. Here also we got benzoquinone, right? Next is, if you add NaNO2 concentrated HCl, that is diazotization, so you will get disonium salt product, right? Then you add concentrated H2SO4, directly you will get para product, that is SO3H will be attached here. So these are the reactions of aniline, right? Okay. Now, last thing about today's class is reaction of disonium salt, right? Reactions of disonium salt, right, students? Reactions of disonium salt you will get here. This is disonium salt, that is benzene. This is N2Cl, positive, negative, right? Some of the reactions we have already done, some might be new to you. Like Sandmeyer reaction we have already done, Getterman reaction we have done. In Sandmeyer you use copper salt. In Getterman you use copper powder, right? You can have chloro, bromobenzene, or even nitrobenzene. I'm saying even cyanobenzene you can have. That is CN can be attached there, right? Next is very important. If you want to get benzene from disonium chloride, either you can add ethanol or you can add PO2. This will give you directly benzene from disonium chloride, right? In the disonium chloride, if you add water and you warm it, then you will get phenol, right? If you add Ki directly, you will get this also we have done. If you add HBF4, directly you will get this by Ball-Schiemann reaction, you will get fluoro product. But if you use NaNO2 with copper couple, then you will get nitrobenzene, right? This also we have done before. If you add NaNO2 directly to this disonium chloride, again you will get nitro product, right? Last is if you add benzene here, right? What will happen? You will get diphenyl product, okay? You will basically, it will be coupling reaction. That is called Gomberg reaction that you will get here. Now, last important thing is the coupling reaction, that is azo-di formation. So remember one thing, if you use phenol, you will have the formation. Basically, what will happen here? Na? What will happen here? This is benzene, this is N2Cl, right? This is phenol, right? This at the para position, this will be eliminated and you will have the formation of this thing, right? That is the coupling reaction. Remember that in phenol you have orange dye, in aniline you have yellow dye, okay? Just remember that thing. Phenol has O in it. Phenol has O in it, so it is orange dye, right? And aniline is yellow dye. Aniline is yellow dye. That's it. Just remember these two azo-di reactions. That's it. Okay? Understood, students? Everybody? Is that clear to everyone here or not? So guys, that was about organic chemistry. All the 4 chapters we have done, right? And I want to see how many likes I have got for this one, right? Let us see, are you even interested and very enthusiastic about your next lecture or not? That is going to be at 6 p.m. Okay? So next lecture is going to be at 6 p.m. sharp. I'll see you, right, where we are going to do inorganic chemistry. And with that inorganic chemistry, very important thing, we are going to do DNF block, coordination compounds and biomolecules also, right, in that thing, right? Okay, so I'll see you at 6 p.m. today only, right, where we're going to do these 3 chapters, right? Okay, then bye-bye. I want to see that how you like the session and are you able to understand everything or not, right? And moreover, one more thing, PDF you will get in the description box, right? With that, you will get some questions that I have formed that are basically your previous year questions from model test paper related to all the things that we have done. What I want you to do, right? These are basically the kind of questions, right, that are for you, right? These are the kind solutions are already given to you in the PDF only, right? I want all of you to download that, right? And after that, try to do the question yourself. Maybe that will not be uploaded by now. I'll try to give you by today only, but by tomorrow you will definitely get the PDF of this particular lecture. Yes? Okay then, bye-bye. Take care. See you all at 6 p.m. Bye-bye. And don't forget to hit the like button and share this among your friends and also subscribe to the channel immediately because you might miss some of the very important lectures if you don't. Right? Till then, bye-bye. Take care.